All right, it's March 25th. Let's do this. I had a very productive day, so feeling pretty good. Now this is my downtime, so let's take a look at the LeetCode Relax Our Brain. Yeah, this is relaxation compared to what I usually do during the day. All right, let's take a look. Pacific Atlantic water flow. Oof. Ooh, doesn't seem easy to me at all. All right, let's take a look. Given a matrix, non-negative integers, okay, representing the height of each unit cell in a continent, the Pacific Ocean touches the left and top edges of the matrix, and the Atlantic Ocean touches the right and bottom. Water can only flow in 4 directions, okay? Up, down, left, and right, from a cell to another one with height equal or lower. Find the list of grid coordinates where water can flow to both Atlantic and Pacific Ocean. The order of return does not matter. Both are smaller than 150. Okay, so these are the heights. So the water can go if they're the same. So basically they're saying the water cannot go from here. Water can go from here to here, or here to here, but from here it's trapped. And here it can go here and then it's trapped. But this one, why can this one go? Water can only flow in 4 directions, so we can flow this way, which means like you can always flow to this. I mean, from here you can always flow out. Okay, so all the edges, so the 2 edges can work. Right, so we start from edges, and then so this one can work, and then if we expand from edges, we look like the directions of edges. Now we know that for example, we go here, right? We say, can this one enter here? If I can go from this to here, then this one is good, but this one cannot. So if this one cannot go, then do I keep looking? Yeah, we're looking for this one, and this one will need to look for, when you look for like all 4 directions, right? So for here, I look for all the directions that possible, right? So if this one is no go, this one, now this one is a go because this one is small, so this one is a go, right? Now we're looking at the go one, like this one's a go, because this one no go, which means if something flowed to here, then it cannot get out. So it's because for this one, the only way to get out is through here, right? I mean, it might be able to through other means. Let me think. Well, if there are other means, then it must be like surrounding it, right? It must be surrounding it. Must have a mean. I'm having like conflict. I have some conflicting ideas that's flowing around in my head. So again, I think the idea is that we have to start from both ends, right? And then if we start from, let's just start from this end first. And then from this end, we need to know if there are any other that is possible. So we look for 4 directions. We cannot look for these 2, so we'll look for this. And this is not possible because it cannot flow to here, right? So this one cannot. But what if, like, say this one is 0? So like say this one is a 4, right? A 4, 3, 2, right? Then it shall work as well. So it's hard to say which one is actually good, which one is actually bad. Because for this one to know whether it's good or bad, we need to know this, we know this, this, and this. We need to know 3, right? But for now, we only know 1. So, I mean, for this one, we're good, and then isn't this like, am I thinking about it the wrong way? I mean, it could be just like a tree, right? So, like a depth first or breadth first tree. I'm basically saying one node, each node has 2 to 4 children, right? And then we start from, if we start from here, right, this one's good, right? Then we don't have like the next one to go. Wouldn't that be like, but if we record every single one, so like for here, we have, that's already like, this one no-go, right? If it's no-go, we mark it as no-go. Yeah, if it's no-go, then we know it's a no-go. And then we move on to the next one. And then the next one, we start from here. And we can only start from the outside. Hold on, what are we returning? Can flow from both, so we are returning the coordinates that can flow. So again, so this one's no-go, and then we look for this one. So we check the edge, right, the outside. We check for this one, and this one we can go here, but this one's already a no-go. We checked already, so we don't have to check it again. And then we can go here, and we can go here. So we branch out. Our branch here, and then we came from here, so we do not go back. We can go, we cannot go here, we cannot go here. This is a no-go. Coming back here, and then this is no-go, right? And then we go here. Here is a no-go, so we know this is a no-go. And this is a no-go. So we have no-go, no-go, no-go. And then keep going. This one we already checked. It's a no-go. So we don't have to check again. Coming here. This one we go here. That's a no-go. We go here. Cannot go. Cannot go. So this one is a no-go. And then we go here. And this is the edge. So that's a go. Right? That's a go. And now we're gonna go second round. Second round. Here we can go here, here, and here. I'm gonna go 3 directions. This is a no-go, so we don't have to check again. And for this one, okay, we go here. And this one we checked already. This is a no-go, so that's a no-go. We can go here, and we go here. Wait, why is this one? Oh yeah, it's just we go here, and then this is a no-go. So this one's no-go. So this is a no-go. Now we're coming here. Can we even come here? I mean, because the water has to flow, right? It has to be from edge, right? So, which means we'll go here, and this is a no-go. We already know. Then we go here. Here we can go here. That's a no-go. We can go here. That's a no-go. We can go down. So we go down, down. This one is a go. So back here, this one is also a go, right? We'll go here. We checked already. That's a go. Now we go here. This one is no go, no go. We can go here, right? Now we go here. This one is no. We already came from here. So we have like a coming from. So I have like a coming from, and we have checked. So from this one, we can go here, or we can, this is a no-go, so we go here. When we go here, we can go, no, this is a no-go. This is a no-go, and this is a no-go. So these are no-go. So this is a no-go, so this one is a no-go. Now moving here, this one's a no-go, 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 so that's a no-go. Moving here, this is a no-go, no-go, and that's a no-go. Coming here, no, this is a no-go. We can flow here, and we can flow here. So we can flow here. Here, this is a no-go. This we check the no-go, so we can flow here, right? And for here, we check no-go, no-go. This one is a go, so we go here, and then we check no-go, no-go, no-go. So this was a no-go. So this is a no-go, no-go. So they're all no-go. From 5, coming here is a no-go. So we know this one's no-go. This is a no-go. We don't have to check. And here, we can flow here, or we can flow here. So if we flow here, I check here, and this is a go. We actually already set up this is a go. So if I can go here, that's a go. So this is a go, right? So we go here. This is already a go. Now also check here. This is, we can go here. This is a no-go. We check already. I go here. We might have checked this already. It's a no-go. And we go here. We check already, and that is a no-go. All right. So because we check here, it's a no-go. So this one will become a no-go. How is this one a go? Oh, it is a go because I'm coming from here. But then where do I go? Water can only flow, right? So when here, where do I flow? I flow here, and I get out. I don't understand. Water can only flow in 4 directions from cell to another one with height equal or lower, right? So for this one, I flow here, I flow here, and this can flow here, and this can flow here. 5, 4, 4. Why is this not right? Like water can flow this way. To both. I don't understand. This is like diagonal. Wait, what? I'm gonna read it again. The right and the bottom, right? Water can only flow in 4 directions. Up, down, left, and right, from a cell to the next one, with height equal or lower. Find the list of positions, right? Where water can flow to both. So that means if water is here, I can flow. Okay, so I think I misunderstood it. I thought you have to go from Pacific to Atlantic, or from Atlantic to Pacific. No, it just means water can flow to both. So if I start from here, water can flow to both. Ah, that's a different question. That's a very different question. Like from here, I can flow to both. From here, I can flow here, and I can flow. How do I flow to the Pacific? Oh, we go this way, right? This, and this, right? And this one's the same. I can go both ways. But this, I can go like this way, and I got stuck here. It can go here, but this one can go, but they stuck. Okay, so my understanding was completely wrong at the beginning. Again, that's fine. We check again, right? So it's still like we start from one point and then see if we can go. So this one, every point, like we start from here, we know that we can go to Pacific, so we need to see if it can go to Atlantic. So that means we have to go, we can go all 4 directions, it doesn't matter. So we go, I got stuck, so this one's a no-go. If we have a no-go and you reach that no-go, then that's actually not a no-go. This is just like if we have a flag, this flag will be, let's say Pacific is 0 and Atlantic is 1, so this one just be 0, right? No, it's like a 0, 1, 0. Pacific is 1, I can go. Atlantic is 0, so this will be 1, 0, right? And then we go here, then we can go here, or here. We can go all 3 directions. So we know that this can go. Actually, at the beginning, we can preset, right? Preset every value. So we know this one can go here, and we can go this. We run 3 branches. That's fine. So we run here, and this one we check. This one is a 1, 0, which means it cannot reach the Atlantic. So we say, yeah. So we say this one is not good, and we can here, and this one came from here, so we also need to make sure that they do not go back to where they came from, right? So like it's like being checked, right? It's being checked. So this is like being checked, and I come here, and if it's being checked, we don't go back, and then we just go for new, right? Right, so every one we can go to the new one. So it's like justifiable of not going backwards. Because if we go backwards, just go back and forth. There's like no point of doing this. So we don't go back. We just we know it's being checked, so we don't go. And then we see this one, we already have it. So this is a no-go, and this is a no-go. So this one is, but it's determined actually by this. If this one is a go, then this one is a go as well, right? So, how can I do that? It's just like this, right? So I'm here, and I think it's just the traverse order. I'm kind of a bit confused about the traverse order. Trying to like in this position, there's too many unknowns, right? So like we can go if we go this way, and we say it's depending on this, but this in turn is depending on this. How do we reason about that? We say that if it's being checked, and I go to me, right, and I say I do not know because it depends on whether you can go. I have something similar before, and I forgot how that was solved. Or do we start from the one we know? A certain, like this point is certain, and this point is certain, can flow to both, right? And then we look around. So looking here, so we want to know if this one can flow. So we know this one can flow here, and then we look to this one, uncertain, this one uncertain, and then this one is certain. Then we know this one is certain, this one can flow. right? And now look at this one. Now this one cannot flow here. It can we look at, or we look around. Like, I know this one is a go, right? So we look around for things that's bigger than me. If everybody around is smaller than me, then there's no chance, right? If this one is smaller than me, because I am, this is the only one. So all of this has to end here. No, why you say that? I could just like straight through, right? All I can say is if there are anything, because I know this one is definitely good, so if there's anything that's bigger than me, then it must also be good, right? So like here, if anything is bigger than me, that's also be good. But this nothing is bigger than me, then what? Right? If you're here, we say this is a good, and then this is a no-go from me, this is a no-go from me. Then what do? Then now I think it should be like, we go row by row, right? We go first row, but we don't know, or we go like that diagonally. So we know this one is good, right? Then we look at this, and it's closer, right? This one is closer, so this, I just need to know if it can reach here, and then if to reach here, we say we can now go this way, we can go this way, or this way, right? So we go this way, and then here, if we go one way, then it's pretty sure we cannot go back. It's only when we do this, right? We have front and back. So I just want to resolve this. That's the only thing that's currently troubling me. If I'm going to do it's like if I go here, right? And from this, I say I came from here. So I came from here, which means I can have a tag for the Atlantic, right? If I go here to here, and then I can pass my tag to the current tag, right? And then I know I can reach here. So for me, my goal is the same, is to reach so I don't go back, because I get my tag from back, so I just move forward. And yes, I think that's the thinking. Because if I say here, right, as I came from here, I say, well, I don't know if I can, as a go or no go, because I will depend on here. But no, it's actually not, because I go from here, so I pass my status, my state to you. So we're both going to be attaching to the Pacific. So your goal is the same as my goal. So you don't have to come back to me. It's useless. You just keep exploring, because you come back to me. It's like if I can eventually get, that means their state is tied. I can actually pass them a reference, right? You think about it. Their state, the state is tied. This state is tied to this state, right? So if this one can find, then this one can find as well. If this one's good and this one's good as well. If this one's bad and then all the tied ones are bad as well. If I'm stuck and you are stuck, then I'm stuck as well. So that means all the adjacent ones that have the same can be assigned the same, like the same thing, right? The same thing. So again, from here, this is a 1, 0, and then we'll look around, can now go. So this is just a 1, 0. I'm gonna go here as a first time encounter, and we set it as also a 1, 0, and then we go here and we say this one's already set. Right, this one's already set. So we say this one is already set, and it's also a 1, 0, so it's basically a no-go, right? Because I want to find 1, 1, and then we'll look here, and this one has not been set, so I come here, I copy, not make a copy, and I give it my reference. I give this my reference. Doesn't that make just things a lot more complicated than it's supposed to be? There gotta be like a traverse way, like a way to traverse this, like just like easy to say. At that point, I cannot go back, right? So at each state, I try, and I say I came from here, so I don't go back. No, I don't have to go back, because if I succeed, this one will receive, right? This one will know. But if this one succeeds, this one will not know. All right? If this one succeeds, God damn. So again, from here, yeah, I just like they could go back and forth. This is troubling me. How do I resolve this? I go from 1, or from 2, right? I can go here, I can go here. I can go, I know this one's a no-go. I can go here, I can go here. And then I move on to these two. So how do I reason with these two? Because I can go back. And I cannot say I do not go back, because I do not go back, and if I got stuck, but from this I can actually succeed. Yeah, I'm trying to, and also look at this example, right? 5 is good, and its neighbors cannot directly use 5. So if we go to the neighbors, and we go to 3, and we see that 3 is stuck, 3 can only flow here, and then from 2 we can flow from to here, and then from this one I can go back. They do share the same state, right? So do you want to share the same state? Oh. Maybe we can share the same state. So like this. like we do a check, like we go from here, we start from here, and then nothing is the same. So we just do this, and then this, we look around, and then we have the same. So they share. I just pass the reference to all of them. So they all share the same state. If I share the same state, then I don't worry, right? I share the same state. And then when I go, I don't go back. I say this is being checked. And then I go to the next one. And then I do not go back. And from here, and now I don't go back, so I go here. So this state is stuck as 1, 0, right? And then coming back, it check its state is the return state of this. Like what? Yeah, like the return state of this. But then it'll be hard to reason. Like if it's the same, then we do not check the return state. We just check the state by itself. If it's a different one, then we check the return state. Right? So here, we go here. We know it's the same, so we don't check the return state because this one can modify its state. And when it modified state, this state got changed as well. All right, so let's say, so this one is just 0, 1, 1, 0, and this one is 1, 0 as well. All right, so I go here, and this one, because I come from here, I say I don't go back. So this one has the same as 1, 0, and then what do we do? And then from here, I go here, I check this one, and this one's no-go. Check this is no-go. And then check back. No, I don't check back. And then, so this one is a no-go, so I don't change myself. So I come back here. And this one, because it's the same, so I do not create a new one. Right? I do not take the return value. Well, I don't have to take return value anyway. So just like go back, I just check its value, and then its value is no good. Right? And now I go here, the value is no good, so this one is a no good. Coming here, already checked, so I don't check again. Coming here, this one I go here, it already checked, so no, this is no good. Coming here, I cannot go. Coming here, cannot go, so this is a no-go. Right? Coming here, this is a go. So that's the first row. Now I go to the second row. This one can go up, but that's a no-go. Can go here, that's a no-go because we checked already. And then we can go here, right? That's a good. And then from here, I know this is a no-go, no-go, no-go. So this one's stuck, right? So it's stuck, coming back. So we know this one is a stuck. So this one is stuck, don't go. Coming here, we'll check, this is a no-go. Coming here, this one, no-go, no-go. This check is a no-go, check is a no-go. Yeah, so like when we do this, if we do like this, row-wise, then every time this one is already checked, and then this one is already checked. So only I need to check is this and this, right? We only need to actually go these two directions, and this one's no-go. Now coming here, this one, right? This one I can go here, that's a no-go. I can go here, but this one we checked is a no-go, right? And that will have a problem. This one is actually, well, I won't say it's a no-go. This one will give us 1, 0, right? This one will give us 1, 0. So I can update mine to 1, 0. So I go here, this one is a 1, 0 as well. So I go here, this was a 1, 0. And then we can go here, and this one is a 0, 1. Right, this one's a 0, 1, and so I can update mine to 1, 1. So this one becomes a 1, 1. right? This one become 1, 1. And then okay, so hold on. I go here, right? And then this one, I check this one. When I check this one, I can now go this, I can now go this. So are you saying that we need to check again? Because if you think about it, we are here, right? We are here, we check this gives us 1, 0, and this gives us 1, 0. This we do not know. So this gives a 1, 0, so we just do 1, 0. This gives a 1, 0, we still do 1, 0. This one we do not know. We need to go here. So we come in here, cannot go, cannot go, cannot go. We can go here, all right? So we come in here, and this one we cannot go, cannot go, cannot go, we can go. So this one gives us a 0, 1, right? This one gives us a 0, 1, and then we're coming back here. This is 0, 1, so I get 0, 1. Now coming back here. So this one gives me 0, 1. So it's a 0, 1. Now this one is, I look at 1, 0, this has become 1, 1. And then I come here, right? Coming here, I don't go back. I go, this is no go. And this is 0, 1. So I become 0, 1. And then I go here, it's a 0, 1. So this one gives us 0, 1. So coming back, doesn't really change much. So it's gonna be what, like OR, right? It's an OR. So it's still 1, 1. So this will become 1, 1. So that's a good one. Now we move on to here. So we need to check every single one. And this one, look, we already, even though we have set this already, but we still check this one is a 1, 1. So we become 1, 1 as well. And then we're good. And then but do we, how do we know that we have checked? So when we reach this, right, every time we reach a node, we need to just look around, right? We look around, but we already checked, right? That's the thing, we already checked. But when we check, we going this way or this way, right? We don't go back. No, we go like these three. We know like this is already done. The things above us is already done. So when we enter this, we use this, we run this and this, we don't keep going. And then if this one is already checked, right, that means this one has gone, like we have already gone to this and then this. I have no clue. It's like if at this position we already checked, because from here we go here and we already checked this one, right? We already checked this one because when we check this one, we say this is 0, 1. So ideally from here when we go here, we should not check it again because we already checked it. Right? Which means we already check it. But we do need to check it again because this one now becomes 1, 1. So this one shall be 1, 1 as well. Reference, right? It seems like we do have to use reference. Every time, if we have the same one, we need to use a reference instead of copying a new one, right? So we use a reference. If we, let's see if we use a reference, right? From here, we can go. We don't go back. Now because this one we say we're already done, right? Every time we visit one, we say it's done. So we go up and then left. No, there's a 1, 0, they're done. Now, new ways are going this way and going this way. And going this way, we see it's the same one, so we give it a copy, right? We give a copy to this one, and then we move here. Now, in here, we have a copy, therefore, this one is a 1, 0. And then from here, we go, boom. We hit this one, we give a, become 1, 1 already, right? And then we can go down. And then if we go down, because it's not the same, so we don't give anything. We give a copy, right? Yeah. If it's the same, we give a reference. If it's not the same, we give a copy. So from here, we give a copy to this. And then from here, I got blocked, and then this is the same, so we don't really change. And then we go back. When we go back, there's nothing to return. We just check its value, right? We just check its value and then see if there's anything we can do. But here, I'm already 1, 1, right? I'm already 1, 1, and then we check this one is 1, 0, and if I just OR it, so it's still 1, 1, right? And then because it's a reference, so this one is 1, 1, like by default. And then we come in here, this one becomes 1, 1. And then if we go here, I say, well, they check it, so we don't have to do anything about it. So we just keep going on here, right? And this one, I think we checked this one already. This one is no good, so we checked it, so we don't have to check it again. And this one, this is no go, this is no go, this is a no go. So this is a 0, 0. Also check. Now we checked. Yeah, so like if we go from here to here, we can now go, like if we enter, it's going to be 0, 0. And then we go here. Now this one we can go, this is a 0, 1. And go here. Actually, who said this is 0, 0? This is a 0, 1. This is a 1, 0. This is a 1, 0. This is a 1, 0. So I see from 5. Right, we just look around, 1, 0, 1, 0, and looking here, this one is a 0, 1. So, like if I already have a value, that means I checked it already, right? Man, that means I checked it already? Oh, yeah. We just need to see if it can reach on both sides, right? So for everyone, we want to see if we can reach both sides. Like this one can reach both sides. I can go here, can go here, so this can reach on both sides. And we know that because we know this can reach this side, and then this can reach this side. That's why we know this can reach both sides. If we come in here, well, if I want to go both sides, I have to go this way or this way. And this way, and that's not the only way. We can zigzag. Man, we can zigzag. Like for this one, we know we can only go this and this, right? And for this, we know we can go this. This we already know. These two we do not know, right? These two we do not know. So we don't do it? like we know this one access here, so we know, but we don't know if it access down. And to know if we access down, we have to go for here. So do I just like say access specific? So left or top, right? So left or top. So these can all access specific, and this one can access this, right? So it's like one run down. We know this is all 0, all 1 0, right? 1 0 1 0 1 0 1 0 1 1. Coming from here, it's the same. A 1 0. This is also a 1 0. This is a 1 0 1 0, and then this one is a for 1 0. We're just looking at this and this, right? This is we can go here, and then we can access here. So it's a 1 0, and this one is a 1 1. So no, this one's a 1 1. Again, here is going to be 1 0 1 0 1 0. This one actually is a 0 0 because we don't know, and this is a 0 1, right? This is 0 1. So we know this. Yeah, this is 0 1. Let me write it down. Kind of using a like slightly different method now. So it's a 5 by 5, right? So we're gonna write a matrix with 5 by 5. So we know this one. So in the first pass, right? First pass we go just left or up. Try to see if we can access specific, right? That's how I think. So starting everyone is 0 0. So we're gonna go first one is gonna be 1 0. Second one is 1 0. Everybody is 1 0. 1 0. But the last one is gonna be 1 1. Second row, it's going to be 1 0, and then this is 1 0 because I can access from top. This is going to be 1 0. Next one here is also a 1 0 because we'll go up or left, 1 0, and then this one we can go up. We found that that's a 1 1. We got a 1 1, right? And the third one, this is a 1 0. And this is also a 1 0. And this will go up or left. That's a 1 0. Next one is a 1 0. Next one is a 1 1. Okay, that's one is not, because I cannot go up. I cannot go up. I cannot go left. No, this is actually 0 0. I was not thinking. My bad. So this is a 1 0. But this one I cannot go. I cannot go. So this one is a 0 0, right? Currently is a 0 0. And this one, I cannot go, I can go this. So this one's a 0 1, right? Next one here, that's a 1 0. This can go, so that's a 1 0. This one cannot go, that's a 0 0. This one can go, so that's, but both of them are 0 0, so I'm still 0 0. This one can go. So this is 0 0, this is a 1 0, this is also a 1 0, so this is going to be a 0 1, my bad, 0 1, this is 0 1. This one is a 1 1. This, but it can go down, so it's a 0 1. This can go up, this, so it's a 0 1. This cannot go, can go, the same, 0 1. And this one is can now go, can go, so it's a 0 1. So the first round we go this. Now the second round we're trying to see should we like starting from which direction? We want to see go right or go down, right? Go right or down. So shouldn't we like start from here, right? Go right or down. So go right or down. We're gonna go like this direction, right? So go right or go down, because we're trying to see if we can access the Atlantic. Now this one we already got it. It's a 0 1. Oh, hold on. So if we just think about that, these should not be 0 1 because yeah, because we're only looking at only looking at, I mean, it's fine. So from here, we'll go right or down. It's gonna be 0, 1. And then I think we're gonna go this one. We'll go right, can now go down to 0, 1. Here, go right, can now go down to 0, 1. Here, go right, can go, but right at 0, 1. Go down to 0, 1. Okay. Now we go here. That is go right, or go down. So actually, if you think about it, this is go here or here, right? So this is actually still a 0, still a 1, 0. And from here, we go right or down, this become a 1, 1, right? This become a 1, 1. Now coming here, go right or down, both give us a 0, 1, so this is a 0, 1. Can now go down is a 0, 1, so this 4 becomes 0, 1. And this, we can now go, but we can go down, so this one gives us 0, 1 as well. And go here, this one we can go right or down, both is 0, 1, so this one update to 1, 1. But here, we can go right, so right is a 1, 1, down is a 1, 1, so this one becomes 1, 1 as well. Coming here, go right is a 0, 1, down can now go. Right is a 0, 1, so this one becomes 0, 1. Go down, I can now go. This one, go right is 0, 1, go down is 0, 1, so this one becomes 1, 1. And this one, go right can now go, down can now go. So that's stuck wherever it is. Right can now go, down can now go. This one is stuck as well. This one, right can go is 0, 1, go down can go, it's a 0, 1, but there's already a 1, 1, so it's still going to stay 1, 1. And here, go right is 1, 1, go down is 0, 1, so this gives us 1, 1. And then for here, can now go, so I stuck at a 1, 0. This one can now go, I stuck. This one, I can go, but both are 1, 0, so I'm still at a 1, 0. And this is 1, 1 already. So if it's a 1, 1, I just I don't check it. And this one can now go, it's a 1, 0. This one can now go, it's 1, 0. This one can go, but both are 1, 0, so I got stuck here. This one, and then eventually we count what are the number, which ones are 1, 1. So we have this. Maybe this is the solution. I don't know. I mean, I am in general very bad at this at this type of problems. I am going to just try to see if this solution works. I don't have like a reason. It's just it feels like that's the way. Like why the first run we always check, we only check to going right, going down. Like going left and going up the first round. Because that's the only thing that we can be sure. Because as we go in the first one, actually we're not sure. It can go down, right? It can go down, but we check up, right? We check up. So every one we check up, and then these things when we check up, it's true, and this thing when we check left, it's also true. So like for this one, up and left is true. So for this one, if we go up and left, we get true values of what I can achieve, right? So after we go this, all of these have true values going up or left. So every one we know have that its neighbors, the up and left, have true values. You go these two directions, we have true values, we know where we'll end up. So after the first run, we have true values for up or right or left, and on the second run, we get true values for right and down. Maybe this is doable. Maybe, I am not sure. I have already spent 1 hour on this question, so let's hope this solution does pay off. If it does not, I will be a very unhappy person. Okay, should be fairly simple to set up the thing. So how do you want to set up? So it's going to be we call it DP. Let's call it DP. It feels like a DP to me. So it's going to be, what is it going to be? We start with 0, 0, right? So we're going to have 0, 0, 4. Oh man, this is not fun. Mn equals land matrix and land matrix. What are you doing, man? Land matrix 0, right? So we're gonna say we're gonna be for in range n, right? And then this is going to be a thing, and then for this in range m, this is going to be another thing. All right, so this is our ultimate matrix. And then first, I'm going to check left and up. All right, we're going to say for I in range, that's going to be I is m, number of rows. For j in range n, all right, we'll check every single one of them. What do? We say if I minus 1 is, so we have 4 directions, right? We have 4 directions. So we should actually get our directions. So no, we only have actually 2 directions, right? We only have 2 directions. So it's going to be for di dj in only 2 directions. One direction is going left, which is don't change I, right? Change j. And the other direction is minus 1 and 0, right? And then we say ni nj equals I plus di j plus dj, right? And then we're going to say if ni is the row is smaller than 0, right? Then we say dp ij or equals no. We can use binary number for this. Binary number. So this actually can be simpler. So this is going to be 0 times n, right? So we're going to do binary number. So we say or equals what? What? What is 1 0? Right? Go Pacific first. 1 0 is 2, right? So we can say this is going to be 2. That's if the ni is smaller than 0. Then we say elif, which means ni is not 0, but nj is smaller than 0. Then we do the same thing. I can combine these two eventually. And else, if ni and nj both are larger than equal to 0, that means we are inside the grid. Then dp ij will be or equal to dp ni nj, right? Which means I can say if this is this or nj is smaller than 0, then we do this, else we do that. All right, I'm going to take a break. I have important things. All right, I'm back. Just fed my cat. All right, that is our first run. And then I'm gonna check again. I'm gonna say check. Check what? Check down and so like if that means this one will only give 1 0 at the beginning, right? And this one is also 1 0, but then we check this, it becomes 1 1. And go here, this becomes 1 1. Okay. Check down and right. So it's the same thing. Okay, it's actually not the same thing. So either range will become bottom right. So it's going to become n minus 1 to minus 1 to minus 1. This one be n minus 1 to minus 1 to minus 1. So we go down from here, this position, and we're going to be either going right, going right, now going down. So this is going down, and then going right will be no. This, oh man, this is going right. Right, this is going right. It's DJ you plug. No, yes, DJ. Yeah, this is going right, and this is going to be going down. Yes, this is going to be going down. So we're going to do this, and then Ni, if Ni is equal to M, and Nj, or Nj is equal to N, then we reach the Atlantic Ocean, which give us 0, 1. So we're going to or 1. Otherwise, we're going to or whatever we have found already. So let's actually take a look. Not 100% sure, but I want to take a look at the DP. You know what? Let's just write it. So now what? Now we're going to say, basically just going to be rest equal to 0. Let's say for row in DP, rest plus equal to row dot count 3. Count number of 3s, right? I have this function in Python, right? Not 100% sure, but I'm gonna just double check. 1 1 3 3. A dot count 1. Yeah, I have this function called count. So I can just return sum row dot count 3 for row in DP, and I need this. We can check. Oh, what's the? Okay, so this is the input case. We only have one test case. I'm very, very nervous. Oh, it's not. Oh man, we got it wrong. You have to return the positions. Dang it. Okay, what am I thinking? What was I thinking? For I in range M, for J in range N. Actually, we will know by now, right? We do this and we say if dp ij equals 3, then we rest.append ij. And then we just return res. Oh man, the res is going to be this. This is turned out to be, wow, way past 1 hour already. Okay, so matrix Pacific matrix. No, it did not pass. I did not pass. Gotta check it again. Alright, back again. Let's take a look. Our results look terrible. Ugh. What do we have? What the heck is this? The result is like all over the place. We're double counting many times. That's because, why were we double counting? Don't we just visit them once? Oh, yeah, we are double counting, so it has to be here. Yep, now we're not double counting, but I think this is every single one. This is not correct. This is not correct at all. Hold on. Let's print the DP. Let's give us. Oh man! Oh wow! Everything has 3. Huh. Okay. Okay. Don't panic. Do not panic. Panic does not help us. We check before. Everything is 2. That is not correct, right? How can, because you're all 2, and we just start with 0, and everyone is either 2 or, okay, let me think. If nj is smaller than 0, yes, definitely, right? But we do encounter some that, oh, dummy, I forgot to put a condition. Ha! It's, oh my god. It's if matrix, my god, n j is smaller or equal to matrix, which is here, Lf this. I forgot, this is very important. Matrix ij, so I can flow to it, then I do this. Otherwise, I don't do it. And it's the same here. I don't know why I didn't include this. Right, this is like very important. I run it. Now I have much smaller space to work with. And is this correct? 40, 40, 31, 30, 22, 14, 13. This is actually correct. Okay. All right then. Let's hope that it passes. If it passes, I become a happy man. Set doesn't matter, right? The return order does not matter. Okay. Runtime error. Index out of range. Oh. Why would index out of range? Oh, here is out of range. Jeez. Okay. I have to consider this. So this will be, oof. Huh. What is this? What is this? Because it says it's M and it could be like skewered or any type of weird shape, and you have not considered that at all. Okay, so we can do this. We cannot do. Oof. That's the only issue we have, right? That's like a matrix that doesn't have 0, which means it's an empty matrix. So we just say, if not matrix, we just return empty, right? This definitely works for this one. Yeah, and then, okay, like, I didn't recognize, do something like this, right? Check. Zero, 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 one, 0, 2, 0, 3. Okay. Want to put this as a test case? Yeah, let's put this as a test case. And that's actually reordered as well, because, oh, I just realized something. If I check this first, then I'll have the same order as the results. Right, this one, get out, put it here, put this one here, then we will have we'll have the same result. And we also need to put this at top, right? So this is going to be the edge case check. So we have one test case is this, second test case that we come up with is basically 1, 2, 3, 4, right? So this is a single row, and expect answer is going to be this. Oh, hold on, what the heck? Okay. Now, right, next one, let's do a single column, which will just be this, 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 right? And we use our newly written solution. It's the exact same, we just change the order, so the result will probably match. Yeah, and then match. So good, and the result is this, right? And of course, we also need to do the single one, which is single one, and all these will pass. All right, let's try it again. Pending, judging, wrong answer. I'm going to check it. I don't have time for this anymore. I'm missing one. I'm missing 2, 1. Okay, so that's fine. Something that we didn't consider. Expected is this. We're getting close, right? Oh. Yeah, the last one doesn't pass. Okay, let's take a look at it's a 3 by 3, right? It's a 3 by 3, so not too complicated. So 3 by 3, we have what? 1, 2, 3, 8, 9, 4, and 7, 6, 5. And we're going to print out the DP in both times, just for good measures. For row, and DP, print row. Right, and then at the bottom, so at both times, we're going to just try print out. Oh, we need a separator. Come on, man. Otherwise, I don't know which one's which. We'll just use our regular separator for this. Okay, so my solution has 1, 2, 3, 4, 5, 6. But actually, it should be 1, 2, 3, 4, 5, 6, 7. Alright, so I match every single one except 2, 1. Right, which one's 2, 1? 0, 1, 2, 0, 1, 2, 1. It's this one. The 6. 6 can flow. Oh. 6, it can flow. We'll go like this. 6. You guys cannot see, but 6 can flow this way. But, so first round, we get, these are all 1s, right? Second round, we go left and up. So 6, so we go left up, it's no go. And the first one, go right. Yeah, we have the same issue. So this is 5. 5, we identify it's a go, but then 6 cannot be. I mean, if you think about it, we have 2 more directions we didn't go. Maybe that's the solution. We need to go all 4 directions, right? So that means we go this. Well, actually, we can also go this way and this way, right? Left and down, and then right and up. If we go left and down, yeah, we probably should. It's like 4 directions, and we will do this one the latest. Actually, yes, we'll do this one the latest. I think. So we go down and right. Then second one. This one will be what? So it's going to be down right, down left, right? So we're going to go down and left. What else? Down left and down left. We have left up. No, we don't want to do left up. Left up will be the last one. So we have right up, right? So it needs to be up and right. So if we go down left, so everyone we're going to check down and check left. So we're starting from this, right? So the I is going to be the bottom. J is going to be ranging to N, right? So it's going to be, we're going to go like this way, right? This way. And then, so we go down and left. If we go down, is going to be -1. No, down is going to be 1. Left is going to be -1. Right? Because we go left with J, yeah, left is this. Now, I, because we go down, so I is still M, but J has to be larger. Oh, it's going to be slightly different if this NI is M, which means we hit the Atlantic. It's going to be 1. That's correct. And I'm going to say Aleph NJ is smaller than 0. that means we hit the Pacific. Now Pacific is going to be 2, right? So that's that. Now we're going to go up and right. Up and right. So we start from this position, go up and right, start from this position, and we go this way. Go to the left. So the I, we're going to be starting from 0, so this is going to be M. And the J is going to be, yes, J is going to be the biggest. And then we're going to go up, this is going to be -1, and go right, going to be +1. That's true. And again, this will be similar to this. So it's going to be, if Ni, so I is going up. So Ni is smaller than 0. Then we can say dpij is going to 2 because that's the Pacific. And Aleph is the same. Nj, because Nj is going to the right. Right, Nj is equal to N. And then that's when we hit Atlantic. That's this. And then, so basically 4 loops and we pass. Okay, I have confidence in this one now. I think this captures the essence. So we're gonna just do 4 loops. Okay. I'm gonna go submit. Pending. Judging. Oh, come on. It's still not right. I'm still missing. Even like doing all 4 directions is still missing things. How many have we passed? Oh, we'll have 2 more left. Jeez. Okay, so this is a 1, 2, 3, 4, 5, 6, 7. This is gonna be a 7 by 7. Man, this is a hard problem for me. Expected. Yeah, I think I'm missing, right? Missing a few. Damn. We're looking for 2 hours this one. I think I'm not giving up yet, but it's getting close, man. It's getting close. Man, how long is this thing? Alright, I'm not gonna do this. Hold on, why is it not working? I don't know, it's not working. Gotta work, come on. There we go. Yep, the last one failed. Which is fine. Well, for one thing, I want to first take a look for row in matrix. I'm going to print row. Let's kind of take a look how it looks like. Damn, it's huge. Oh, it has a lot more rows than column. Ay, ay, ay. So we're missing which one? 22, 2. Well, 23, 2. Everything else is there. 33, 1, 33, 2. So we're missing 23, 2. What the heck is 23, 2? 23. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Yeah, this is 22. 22, 2. 0, 1, 2. This one. How did I miss this one? It's the largest number. We can go this. Cannot go this way. We can go, oh my god, this is is there like another orientation we haven't considered? Oh yeah, there are. We have, if we consider like every two, if a 4 choose 2 is what? 4 choose 2 is 6. You only consider 4. There are 2 more, up and down, left and right. But at the end, like you have to justify yourself, like why this will work. Are you gonna do this? I'm not even sure if that is correct. Like, why don't you go 3 directions? All right, let's just. Oh my god. Seriously, this is where we at. Like, yeah, indeed, we have 2 more directions we haven't taken, which is up and down, and left and right. Right? That's the 1 we haven't checked yet. So if it's up and down, where do we start? Exactly. If it's up and down, where do we start? Well, up and down, we can start from. I don't know where we start from. If we go up and down, we need to start from the first row and the last row. And then we, like, first row and last row. First row going up, last row going down. Or I don't know. Like, or we just look around. Like, okay, so I have another idea. I think instead of doing this, we let's say we did all of these, right? We did all of these from 4 corners, right? That's what we do. And the last one, we're just gonna go for 4 directions. Every single one, we're gonna go for 4 directions. Oh, this is too complicated to debug. So I'm not even trying to debug this. It's just basically just thinking what could be the way that we haven't considered. I mean, write down, we consider this, we consider this, consider this, consider this. And the other thing we need to consider is, like we say, all over. Basically, it's not matching that because that value is like some direction some value has, like there's one more hidden update that we haven't done, right? And there's a reason that we can do this way because we say if we go this way, it's always, you know. So like if we go this and this, maybe it's because you're doing it wrong. Because I'm doing this way, but I'm actually going. Yeah, but it's fine, right? It's fine which way you go. Like if you go this and this, we can run like vertically, or we can roll horizontally. Are you saying we need to go it 2 ways? It's ridiculous. This is ridiculous if you really need to go like that. But if you think about it, yeah, because we say go this. Huh. Then why do we go both ways? Like if I'm going this way, and then I always look to the left, because we look to the left. So everybody look to the left. Everyone look to the left. And everyone look up. Everyone look to the right. Everyone look down. That is an interesting idea, which I want to explore. Which means for this direction, we have to do, like from here, everyone look left. From here, everyone look up. Look up, look up, look up, look up. Look up, look up. And then we're going to look right, look right, look right, look right. So it's going to be like going this way. Everybody look right. We're going to look right. And then we're going to go from this way. Everybody look up, look up, look up. I am not sure, man. I'm honestly, to God, I have no clue at this point. It's just like everything is so... I'm so done. Alright, so I have my original code here. So I'm going to save this somewhere else just in case I mess around. It's just pretty hard to write this thing. Anyway, so okay, your new idea is only to go one direction, right? And I want to go like this at the end. So maybe we'll look left at the end. So let's look up, right? Let's just say, let's check up. Let's look up. And I'm going to start from here, looking up. And it doesn't matter if we're looking up. We can start from here or start from here. Let's just start from here. Then I, right? If we look up, for I in range M, and for J, J will be, so we're gonna go, so it's actually for J in range N, and then for I in range M, right? And then we say Ni, because we look up, right? We look up. So Ni, Nj equals, if we look up, then it would be I minus 1, right? And then J. Nj doesn't change. And then we say if we look up, just the one above us, if Ni is smaller than 0, then dp ij, or, and, so that's connecting to Pacific, right? The Pacific is going to be 2. Else, then it's going to be this. So that's checking up. Right, and delete everything else. Well, actually, don't want to delete it, just delete one of them. And then next one, we're going to go say check up. Let's check down, right? Check down. It's fine. Check up and check down. So check down. Let's also start from here. So J gonna change. J gonna be this, because J starts at the bottom, and I is, I think you're wrong. J is always here. I is starts at the bottom. Minus 1, and minus 1. So I start at the bottom, so we go this way, right? And every time we check down. So Ni will be plus 1. And then we say Ni equals to M. Then this is going to be connecting to Atlantic, right? Next one is going to be check right. And check right. So we're going to start from here, right? Let's start from here, which means I is going to be range M, J is going to be N minus 1, minus 1, minus 1. And I does not change, but J, because I'll look right, J is going to plus 1. And then it's going to be Nj equal to N. If that's right, then we're going to, that's going to be 1 because we're hitting Atlantic. And finally, is going to be check left. Check left, And then this is going to be n. Then it's going to be -1. And check left, smaller than 0. It's going to be 2. And then I'm also going to put res here. Res equals this. And then we say this. No, not here. Check left. Oh, I put it in the wrong position, man. It has to be like before here. Res equals 0 is here. And then after check, we do this. And then all these gone. All right, so we have check up, down, right, and left. Ew. I think it's even more wrong. Yeah, it's even more wrong, man. It's even more wrong. Even the initial case doesn't pass. Even the initial case doesn't pass. Oh, I know why it doesn't pass. Because, oh my god. How come you are so dumb? We forgot to do elif. dp ni nj has to be smaller or equal to dp ij. Every single one of them. I forgot this. Okay, so if we have this constraint, we still, oh man, we still do not get it correct. How? I look up. So you cannot just look up. Okay, I have another idea. I mean, this idea apparently is not right because I only capture these two. Why? So if we go up, I have another one. Let's pull this one back. No, this is an even wider idea. I am going to go 4 directions. 4. But we're going to run it 4 times. And each time start a different position. We're going to run the time here, run it here, run it here, run it here. This starts to shape like reinforcement learning. You know, just keep doing it, and eventually you will hit. Okay, so we're gonna start from. There's not gonna be any directions. So it's just gonna start from one point. Start from here. We're gonna look in 4 directions, all 4 directions. So it's gonna be all 4 directions: 0, -1, and 1, -1, 0, right? And I'm gonna say if some of them hits 1, if it's like going over, it's this, and then elif in I smaller than 0 or in j smaller than 0, then we say dpij gonna be 2 because that's specific. Else, for this, it's gonna be like this. Okay, so basically we're gonna repeat this 4 times, right? We're gonna repeat the exact same thing 4 times. So I'm gonna say start bottom right. This is gonna be start I is gonna be here, so it's gonna be bottom left, right? And then we're just gonna swap out this thing. Then this is gonna be start up right, right, upright. Yeah. And then last one, start. And we all go like row first. And maybe we should do column as well. This is upper left. Upper left. Let's hope we don't have to. Then we can run. This one can pass. They all pass. Ooh, all right. Let's try this. Trial and error. Submit. Judging. Wrong answer. Ah, of Lord. I don't even want to know what this one is. How big is this thing? This thing is huge. My editor just froze on me. Oh. So we have this, and we have the expected. Still one missing. Man, it's just a constant struggle of missing one. Unbelievable. I think I kind of know. Does that mean we really have to do? I mean, we run it. Yeah, the last one failed. God. We have to go vertical as well. I mean, that's the only thing I can think of, right? We start from each position and then we run it twice. One time going like row by row, and the other time we have to go column by column. Please don't be like this. Please don't be like this. I mean, this is the same thing, so we can actually write a function for this, right? We're gonna say, I should not want to write it here. We're just gonna have def check. Right? When check is gonna be ij, and then we just run this. God, what are you doing, man? Yeah. So this is just check, not check. Evaluate. Right? When they evaluate, then yeah. And then what we need to do is just like this. I'm going to call evaluate ij. And then I'm going to pick a different orientation, which means we're going to go j first, right? Go j first, and then I. So if we go bottom right, so instead of going row by row, now we're going column by column. So same thing here. I'm going to do, no, what are you doing? We're going to do evaluate ij, then we're going to do the same thing again, this time j first, I second. If this is the case, this is most likely the case. This is going to be evaluate ij, then do this again, but do it this way. So okay, and the last one is actually we will evaluate ij, right? So this is the last one, but we're going to save that for the last. And this one does not require checking because it's not ready yet. I'm going to go j first, then I. Okay, and then like this. Now we all pass. Now we pass. Now I think we pass. We just, oh my god. Oh my god. Yeah, I think this, unless it times me out, then I'm gonna, please don't time out. 1 hour 48 minutes. Yeah, I was begging that it does not time out. Oh, the runtime. Yeah, I don't want to see it. Ooh. Hey, we passed. So, but oh, it's definitely much shorter than that. Okay. This is a terrible solution. What I have. Terrible. Terrible, terrible, terrible. I went all directions. There's no, yeah, this basically at the end, like just, I throw everything on the wall. This one stuck. And then I was like, okay, that's it. That is the thing. I'm going for it. Actually, I'm gonna put the rest at the top so everything looks more, more uniform. Man, this is a terrible performance. This calls for vengeance tomorrow. So like this idea is just start from each position and then you just go all 4 directions. It's like reinforcement learning. You encounter it sufficient number of times, and then the true value will show. And this is exactly what it is. And it's just like the order matters. All right, I don't want to write too much of this because I think this is a bad solution. Now this is apparently a terrible solution. Basically, we start at each corner and run both horizontally and vertically to traverse through all cells. And for each cell, we also examine all 4 directions. Maybe we don't have to examine all 4 directions. If you think about it, what's your time? If we're cutting half, well, cutting half is 9. It's still terrible. So no, it must be a better solution. We also examine all 4 directions, and eventually, after we run this, we will have covered all possibilities. This is going to be O(n) squared, but that's going to be like O 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 times 4 times m times n. So it's bad. It's very bad. And we have a 1,864 milliseconds, which give us a 8% ranking. My God. Yeah, it's very, very bad. All right. My brain is about to freeze. Let's just take a look at the solution. Oh, graph. Yes, it's graph. Why did you think of that? It's graph. Another graph I had previously had a graph, but I mean, basically it's just graph. Oh my god, oh, what the heck? Anyway, ah, man. DFS, DFS. Oh, man. All right, so let's read about it. Ah, yes, this is a graph representation. Check every cell, iterate through every cell, and at each cell start traversal. Find every cell that managed to reach both oceans. It's extremely slow, repeats a ton of computation. Instead of looking for every path, let's start at the oceans and try to work our way to the cells. This will be much faster because when we start a traversal at the cell, whatever result we end up with can be applied to only that cell. However, when we start from the ocean and work backwards, we already know that every cell we visit must be connected to the ocean. Yes? And flip the condition. Check for higher height instead of lower height. Yes. And we know that every cell we visit during the traversal can flow to that ocean. And let's figure out what cells can flow. Yeah, and the cells that end up connected to both will be our answer. Okay. Didn't you think about this already? Right? You thought about it, and then you gave up. Because I was saying, if I have this condition, which way should I go? Ah, it doesn't matter. Because I can go this way, I can go this way. Let's see. Initial ocean, Pacific. All Pacific Ocean cells. So it's just traversal. So for here, we go. So these are all good. Now we start from every single one of these because these we know are good. And then if this is already good, we only check. Now we go check here, and then this is good. And then from here, we're going to flow. So these are all good. And then we cannot flow, we cannot flow. Then we end here. That is actually a better one because we start from the ocean. Instead of, yeah, if we start from the land water, we try to figure out if it can end up in the ocean. Then we will, then the starting point is unknown, right? Yes, the starting point is unknown. Yes, that's why you got stuck. Because the starting point is unknown for me, right? I say the starting point is unknown. I say whether I can flow from 2 to the ocean. The starting point is unknown. So if I flow to the next one, this one's double unknown. However, if we think of in reverse, I think this is like how many times? I always think in reverse. Then the starting point is none. Then we can go to any position. We all know that. Ah, yeah. And then we're going to start from this, going up, and then lay both, and then we find out. Ah, yep. We can implement this. I think I will like a DFS better than, so like maybe less code. We have to implement this. Like there's no other way. We have to, because our solution is too ugly. Way too ugly. All right, so I like how we start. So I'm going to use the exact same thing. Right, and then we're going to say a def DFS ij, right? We comment ij, and then what do we say? We say that for 4 directions, I use this. Actually, we're going to use all this. So for each thing, we need to look around, right? Now, when we look around, we need to see if it's set, right? If it's set, then we don't go there because we know we already been there. So for each one, we're gonna go like 4 directions, right? And then go these directions. When we go these directions, if it's good, it's actually we are going to say, instead of I depending on the other one, we're going to say the other one going to depending on me, right? So everyone will look. Wait, hold on. Hold your horse. Hold your horse. I start from here, right? And then I start traversing. And I can go here, I can go here. And when I go here, I keep going. So everyone, we just traverse until we cannot traverse anymore. And if we have visited a cell, right? So like I am on a cell, and I know what value I am. And because I am at a cell, that means I know, like I have truth. And I look around, right? I look around, and I'll go to the place. I'll go to places that I know, and I'll set its value. Yeah. So I have value that I know, which is and we're gonna go. How are we gonna visit it? Just the first row and the first column. I think that's how we do, because the first row is all certain and the first column is all certain, and we're gonna traverse based on that. And if a value, if a number, if a cell has been visited before, and it's the same value, then we don't do it. Yeah, because we want to only visit each one at most once, right? So if I traverse, if I hit it already, then I do not. Yeah, if I hit it already, then I don't go there again. So this is the start. Actually, this is not the start. We can fill this one and this one, and then we can go. Actually, we should. Yeah, let's fill it first. So it's gonna be like this. First row. So pre-fill. The rows that we know. Pre-fill rows. Pre-fill DP will be for J in range N DP 0, right? J 2. No, what are you doing? And then we also say DP M minus 1 J. That's Pacific. That's Atlantic. And then for I in range M, right, DP I 0 2 and DP I N minus 1. Right, so this one is, and then this, right? 1. So this prefill. And then when we hit, we go this, and then we say, what do we say? We have if in I, if 0 is smaller or equal to n and smaller to ni, smaller to m, and 0 smaller or equal to nj, smaller than n, right? And dp ni and j has to be larger or equal to the not dp matrix ij, right? So dp is matrix, so we can flow back, right? When this is true, we say matrix, now we're going to do dp ni and j, because I can flow from dp ij, and after that I'm going to visit dfs ni and j. Then we have another condition, that is like if it's not 0, then we don't visit it, because if it's not 0, it must be visited already, must be updated already. So I don't have to go there. Do I have to visit a cell that has been set already? Well, a cell can be set. For example, I can set go here. Do we go here? Well, we do not go here, because this one we will visit. So we say we do not go. So basically the first one we just like this one we do not go. On this one we do not go here, but we go here, right? So we go here, and then now we are here, and this one is none. And then we try to go. We can go here, but this one is set, so we don't go. And this one can go here and go here. And then we keep going. Now this one cannot go anymore. And then, so if it's set, then we do not go. And when we do the other way around, right? When we do the other way around, how do we set things? Like if we can go, we go. If we cannot, if a cell has been visited before, then we don't visit again. So we can say that would be the sentinel flag, right? We say if dpij equals flag, which means it has been visited before. Has been visited before. Okay, so if it has been visited before, we just return. If it has not been visited before, then we do, right? So we say for so we're going to start from this and from this, right? So I'm going to say for j in range n, we're going to say dfs 0 j, and our flag is 2, because if it's 2, That means we have visited before. And then first column for I in range M, DFS, I, 0 is also 2. And then same thing for J in range N, that can be the last row, so it will be M minus 1. This one will be 1 because we're doing Atlantic Ocean. If it's 1, that means I have visited this before. If it's not, then I can go. Then this one is the same, I in range M. So we're doing this column, so it's going to be N minus 1. It's going to be 1. So we do all these DFS, and at the end, we're going to say res equals 0, if now equals 0, s equals, actually when this direct return, ij for I in range M for j in range n if dp I j equals 3. Okay, let's try, see if this solution works. Oh, we're missing a flag. Where? Oh, missing here. So we just use the same flag here. Maximum recursion depth found. Huh. And the first one is fail. We have some success. Okay, so go back to drawing board. We fail this one. Okay. We can actually take a look at the say print dp. That's weird. After the first, why would we have 1? Like, oh yeah, because we already. Ooh. That's true. That's true. So let me say for row in dp print row, right? So this one we're looking at this thing. And all these can access, all these can access. And then, like, how come this is not accessible? Like, you have a 0. What I'm doing from this to this, and you're not coming down. How? It's like the DFS is not working, huh? Yeah. It's like the DFS is not working. Oh, shoot. Because it's not visiting anyone. It's not visiting anyone. Did I say if it's equals flag, then I don't do it. But you have to start from each one. But if you do start from each one, and you go down, and you go here, you say, no, it's, don't want to. Ha! How do I resolve this? Like, I need to start from here, but Yeah, they're not going anywhere because it's already flagged. How do I make sure that the nodes don't get visited again? Well, I have to go there. Hold on. I think I have to update the value to everyone, but which one to go? So we have this, right? And then we say the next one to go. So say to go. It's going to be like this. And we say if dp nij is not equal to flag, then to go dot append nij, right? And then I update its value. Now after this all done, I'm going to say for nij in to go, I'm going to dfs nij and the flag. Something like this. We'll have maximum recursion. Shit. Oh, so it's not flag, then I go. Why would I have a maximum? Okay, let's just fix this one. Let's see. No, it's already infinite loop. So I'm here, right? And I say if the next one is larger than me, right? And then I say if it's not equal to flag, this is equal to flag, so I'm not going here, I'm not going here, so I'm not going to this or this because they're already flagged, right? So if I can print out, if I can print ij and to go, and take a look. So first one 0 0, yes, and next one is 0 1. Next to go is 1 1, good. So now 1 1. Next to go is 1 2 and 2 1. That's correct. Now we go to 1 2 and 1 2. I can go 1 3 and 2 2. 1 3 and 2 2. Right. So we go to 1 3. At 1 3 we can go to 0 4. How can you go to 0 4? Wait, you're at 1, no, you're at 1 3. 1 3. 1 0 1 2 3. You can go to 1 4. Yes, 1 4. So we go to 1 4. 1 4 you can go to 0 4. Huh. I think that complicates things. That complicates things. Let's preview later. Let's just do the two, like the preview has to be accommodated, right? So this is the first time we do preview, and then we're going to do another time, and it's going to be here, and it's going to be here. Right. And then the prefill will happen at different locations. So let's just say when we do 2, we do the prefill for 2, which means it's here, right? Before we do the No, that's here. 2 is here. It's going to be here. So that's the prefill. And come out this one. And that's a prefill. And that's the, I think yeah. Just so that we're on the same page. Right? There's another preview for this Atlantic. This is going to be for Pacific, right? And do it. That looks more correct, right? That looks more correct, and then we can actually lose this one as well. So 2 rounds. Yeah, I think this one is correct. And we don't need this anymore. And we can let these 2 go as well. Oh. 1 or 3, I think. You know what? You know what? To make this even simpler, just come with me. So, in the prefill for Pacific, it's going to be this, DP, P, right? DPP, and flag, and DP. And DP, we're going to pass DP into it. And here, we're going to pass, right, the prefill. After we prefill it, we do DP PA Pacific. It's the PAC. So we know what this stands for. So the Pacific. And then here we're going to do DP Pacific, right? And then we'll do the same thing here. So these DP will become Pacific. And here it's going to be Atlantic. So all this DP is going to be Atlantic. And we're also going to pass Atlantic, DP Atlantic here, right? So once they both have it, now we just need to say if DP Pacific or DP Atlantic, okay, equals 3. Run it, pass. There we go. I think that is the solution. Yeah. Yeah. So we do have to, okay, let's try everything else. Everybody pass. So we're going to say to go to next state, next cell, only if it has not been visited. Has not been visited. In the current fill. In the current be visited from the perspective of the current ocean. Right, so we just prepared 2 DP table, and One is this, which allows us, I mean, we can even do this, right? We can say if, and then we can say if I is smaller, it's hard to justify here. Yeah, I'll have to fill it here. Pre-fill here, run it. Pre-fill again, run it, and then we check. Say flag determines which ocean we are concerned with. Flag equals 2 if the traversal originates from the Pacific. Flag equals 1 if originates from the Atlantic. Okay. We just say fill DP for Pacific, right? And these are defaults. Pacific defaults. This is also Pacific defaults. And then can we maybe, I mean, if I don't pre-fill it, I will traverse through it, and then, let me think. Nah, probably not. But maybe, so I can make it like less convoluted, right? I can just say do this and then immediately traverse. And it's the same thing. So do this and then immediate traverse. See, yeah, it works. Yeah, because I will be traversing everything, and then the next time when we hit, right, then it will be already traversed. So we'll have to traverse again. So I think this one works. This is set default, traverse from default. Right, let's save all this, save all these lines. This is the same. This line can go here, and this line can go here. Let's save lines. First set default value on the first. We set default value on the first row and first column, then traverse from each default cell. So we don't even need this, right? This will be same, but just a bit different from the last row. And last, yeah, and okay, I'm gonna turn this. We're gonna put this one through. Change it to here, and now I'm gonna run it. Pending, judging. Oh wow, so much faster. So much faster. Yeah. This is the official solution. Much, much faster. We run from the ocean inward because that way each cell we traverse has a certainty regarding its relationship with the ocean. Since there is no ambiguity, traverse is straightforward. We can be certain that a visited cell does not need to be visited again. We use 2DP matrices, 2DP matrices to facilitate two runs, one from the Pacific, the other the Atlantic. So this is going to be OMN, and then we're going to 312 milliseconds, 39%. Good. I think we probably have done it a bit easier than what they do, right? We have a set reachable DFS, blah blah blah, continue, reachable, continue, after this, continue, and DFS the next one. Oh, intersection. Oh, hold on. I think this is better than my implementation. They don't have to use a DP. Row column, we have Pacific reachable, Atlantic reachable. And then we do this. Cell the reachable, so we mark it. And then we go for directions. And then we say the next one, yes, is within the bound. So this is without outside the bound, we don't consider. If it's within the bound, it's already reachable. Then don't check again. So it has a higher or equal height. Yes. If it's smaller, then we don't do it. Otherwise, we go to the next one. And then for every one, number of rows. So we say Pacific reachable is on the top, not on the left. Atlantic reachable is going to be on the right. Yes. Now we intersected. Wow. What beautiful solution. Very beautiful solution. I want to implement it. Wow, the reachable. Wow. Very, very good. Yeah, float from the ocean. Yeah, I wanted to do like this is okay. This is not the official solution. This is my interpretation, my implementation of the official solution. Let's do solution 3. I really like it. I think that captures everything. So this is the actual official solution using DFS. Very, very good one. So, I mean, the good part is they're not using, yeah, they're thinking about like reachable. If I can reach it, then I don't have to start from there again. But why? If the next one is reachable, oh, because you only set that it's reachable when you visit a cell. Yeah, that's the thing, right? Because I set it before I reach the cell. Then I have a little bit complication on which cell to go to. Yep, it's gonna be full on whatever is there. I like it. I like it a lot. And then P reachable and A reachable, right? And be 2 sets. And then DFS, DFS, and be IJ reachable, right? And then first thing, if I get there, that means I can reach. So I'm going to be dot add IJ. That probably has to be, wait, a set. I can only add this. Only a tuple. Right. So we add this, and then we say for the 4 directions, so say for 4 directions, I have new, and if it's good, then if it's good and Ni and J not unreachable, and we have all these conditions, then I say DFS Ni and J unreachable, right? Then we do for I in range M. So we do the first column. We say DFS I 0. That's Pacific reachable. And then we go the right side will be I and N minus 1. That's going to be Atlantic reachable. And then we say for J in range N. So it's be DFS first row J gonna be Pacific reachable, and there's the last row gonna be Atlantic reachable, and then I'm gonna return P reachable dot intersection A reachable. This is such a good solution, man. Look at this. If I were to turn into a list. Yeah, it's not gonna pass here, but I think I'll pass. Actually, we can try. Maybe this one will suffice. So much shorter. Yeah, I think it suffice. Submit it. Oh yes. Oh yes. This so elegant solution. OMN. We run at 276 milliseconds for 84% ranking. Yep. I should be able to think about this, but I should be able to come up with probably not this, but the reverse idea. I shall be able to, but wasn't. And I was using this ugly as hell. Alright, anyway, that's it. That's it for today. 2 hours and 39 minutes. Got stuck. Very interesting, huh? Yeah, very interesting. Alright, that's it for today. See you guys tomorrow. Adios.